Okay, so I want to find the partial derivative of x of this function given um, f of xy equals to 7x over x plus 5y. So if I'm trying to find the partial derivative in respect to x, right, we have to, we technically have a quotient, right? So we have to do the quotient rule. So what is the derivative of f? We make the top part our f, right, and we make the bottom part our g. So derivative of f in respect to x is just 7, and the derivative of g in respect to x is just 1. So from there, we're going to do, remember, derivative of quotients or fractions, rather, is f prime times g, right, minus g prime times f all over g squared. So that'll be 7 times x plus 5y equals, not equals, minus 1 times, what's my f, 7x all over x plus 5y squared. So we distribute the 7, and that gives me 7x plus 35y. Distribute the minus 1, and that'll give me a minus 7x. And again, that's all over x plus 5y squared. So that should equal the 7x is canceled, 35y over x plus 5y squared. And that will be my answer. So, I think that should be the logistics or the logic of pretty much finding the partial derivatives. The only, I guess, maybe tricky one could be if finding the partial derivative of x and y at the same time. For, let's say I'm going to give you the function f of xy equals to 7xy cubed minus 5xy plus 3x. So if I find the derivative of f of x, or fx first, I find the derivative in respect to x. So derivative of 7x will just be 7, and then I'm left with the y cubed. Derivative of 5x is just negative 5, and then I'm left with the y. And the derivative of 3x is just plus 3. So then my next step is, since I'm taking derivative of x, y, right? Well, before I go on, let me clean this up just one little bit. This will give you 7y cubed minus 5y plus 3. So now the next step is I'm taking the derivative in respect to y. So the derivative of 7y cubed should give me 21y squared. The derivative of negative 5y should just give me a minus 5. And the derivative of a constant is plus 0, but again, we don't walk around saying plus 0, so we just eliminate that. And then that will be your final answer. So if I do one more, I guess in that same kind of thought, let's say I give, say find f of xx equals to, not xx, xy, equals to 8x squared y squared minus 6x y squared plus 4x, right? So again, I find the derivative in respect to x, right? So derivative of 8x would be giving me 16x y squared, and the derivative of the negative 6x would just give me minus 6, and then derivative of 4, x would just give me plus 4. So oops, now let's off my y squared. So we can't combine any terms, so now we move to the next step, which would be find the derivative of y. So the derivative of y squared is 2y, and then the derivative of 6y squared would be 2y again, right? And then derivative of 4 is just nothing but plus 0. So to clean it up, 16 times 2 will give me 32xy minus 12y, and then no need to put plus 0. So that's derivative, or the partial derivative of x and y. So you have plenty of homework to do. I suggest you do it. I take that back. So there's one more thing that you do need to. Now,